All right, ladies and gentlemen, welcome to this recording of the Algebra 2 Test 1.3 review. Let's start with number 1. F of x equals negative 3x minus 6. Find f of negative 4. Okay, well, this is pretty simple. We're just going to plug in negative 4. So we're going to do f of negative 4 equals. Okay, so we're evaluating f of negative 4, and so what we do is we just write negative 3, open parentheses, negative 4, close parentheses, minus 6. So that is going to equal positive 12 minus 6. We always want to write the complete sentence. I know it seems cumbersome, but you want to make a complete sentence. So f of negative 4 equals 6. This is an x value. This is a y value. Okay? So the graph of that line would contain that point. Okay, we're on to number 2. And the question is relation t a function? Is the inverse of the relation t a function? Well, let's first check this first question. Is relation t a function? I don't see any repeating x's, so yes. Yes, it is. Now, is the inverse of relation t a function? Well, in order to do that, we just have to switch the x's and the y's and see if it's a function. The real easy way to do this is to just look at the y values and see if they repeat. Do any of the y values repeat? No. So since none of the y values repeat and none of the x values repeat, both the inverse and the original are both functions. Because we know that in inverse functions we're just switching the x and the y, right? So you just flip-flop, 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 and that means that all of the y's become x's, and since none of the y's repeat, the inverse is a function. And that is the end of number 2. And ladies and gentlemen, here we are with number 3. Okay, number 3, we are asked to evaluate f of x at negative 1. This is not a major undertaking. It's just going to be f of negative 1 equals negative 5, open parentheses, negative 1, minus 3. Okay? So f of negative 1 equals 5 minus 3. And we can use our symbol, therefore f of negative 1 equals 2. Okay? You can always plot your solution, negative 1, comma 2. So if you graph this, and you graph that point, you'd find that it lay on the line. And that's the end of number 3. Okay, here we are on number 5. Let f of x equal 4x minus 4. Find f of 3. Couldn't be simpler. Guess I'm doing this one in red. F of 3 equals 4, open parentheses, 3, minus 4. So f of 3 equals 12 minus 4. Therefore, f of 3 equals 8. And that's the end of number 5. And we are now on number 6, ladies and gentlemen. Find the inverse of the function. Oh, we're finally going to do something interesting. So to find the inverse of the function, does anyone remember the first step? First step is to just scribble this out completely. And what am I going to write here instead? Write y. So let's write y equals, and then 7 over 8 x plus 14. And now what do I do? So we're going to swap the x and the y. Yep, we got to swap the x and the y locations. That's why I kind of highlighted them there. So x is now equal to 7 over 8 y plus 14. How about now? What do I do now? So first step is to subtract 14 from both sides. Now we can't take 14 from x, so we just write x minus 14 equals 7 over 8 y. Now we do what you were saying. We're going to multiply by the reciprocal of the y coefficient. What on earth does that mean? Flip it, right? That's how normal humans would talk, yeah? Flip it. So multiply both sides by 8/7. Is that what you're telling me? I would recommend this. Put it in parentheses because otherwise you might mess up. So multiply both sides by 8 over 7. And the reason you're going to need to put it in parentheses is because on the left, you're going to have to use the distributive property. Here, the 8's cancel, the 7's cancel. Y is now isolated by itself. And remember, y is our inverse. So we're where we need to be. We could stop here, and this is like legally a legitimate solution. But we're going to go ahead and distribute the 8/7. So all I get is 8/7 x. And now I've got to do a little math. You know, I'm not big on my 14s. I didn't learn those. So that's what, 32, carry the 3, 112. Does that look right to you? 14 times 8. So I've got 112 over 7. Are there any common factors? I'm saying between 112 and 7. Like, let's try to divide by 7. 7 goes into 11 once with 4 as a remainder. Hey, 16. So let's just check. 16 times 7. Let's see if that really equals 112. 2, 4. It does. So here's what we can do. This just becomes 16. Okay? That's what that means. We can just cancel this and cancel this, and this just becomes 16. So let me just make an arrow, okay? Y is equal to f inverse x, okay? So we already know what y equals. Y equals 8/7 x, and then we already found out that 112 divided by 7 equals 16, so we're just going to write 8/7 minus 16. I mean, if you turned in 8/7 x minus 112 over 7, I would take that. I wouldn't have a problem with that. And that's number 6, ladies and gentlemen. Done. All right, ladies and gentlemen, here we are with number 7. Let f of x equal negative 3x minus 6 and g of x negative 2x plus 7. Find f of g of negative 2. Well, you know me. First, we're going to find f of g of x because that's really what we're doing. So f of g of x is exactly the same thing as saying the composition of f and g of x. And what that's going to be equal to is we're going to use f as the kind of frame, right? So we write negative 3, and then we put some huge open parentheses here because we're going to stick this whole thing in here. And then we put minus 6. So now we stick this whole thing in there. Let's choose a cool color. Negative 2x plus 7. And that's g of x, right? So now we're about to do it. Here we go. So choose your form. You know, this is the same as this. So we can write it either way, but we'll just go for it. There's negative 3 times negative 2x. That's positive 6x. Negative 3 times 7 is negative 21 minus 6. So that's 6x minus 27. Any common factors there? 3, right? Divide a 3 out of both. So I'm going to pull out a 3. It's like reverse distribution. The 3 comes and sits out front, hangs out up here. It just simplifies things. So we put a 3 out front, open parentheses. Now we got 2x minus 9, right? Y'all understand what I just did? Okay. So that's f of g of x. Well, now we just want to evaluate f of g of negative 2. So everywhere we see an x, we're going to put a negative 2. So 3, open parentheses, 2. And then I'm going to do open parentheses, negative 2, close parentheses, minus 9. It's really not that much more difficult than that. So that's going to equal 3, open parentheses, negative 4 minus 9. Negative 4 minus 9 is negative 13 times 3. I'm not big on my 13s. What is that, 39? Does that look right to you? So f of g of negative 2 equals, is it going to be positive or negative, ladies and gentlemen? Think about it. It's 3 times negative 13. Negative 39. So that's messy. But we're done with number 7. So I want to write it clearly because there are going to be people watching this who want to see clarity. F of g of negative 2 equals negative 39. There. All right, ladies and gentlemen, here we are with number 8. Find the inverse of the function. Well, the first step to finding the inverse of a function is to just scribble this out completely. We don't need that. This needs to be a y. All right, that's step 1. Now step 2 is to swap the x and the y. All right, so instead of y equals 2/5 x plus 2, we're going to write x equals 2/5 y plus 2. That's all I've done is swap the positions. Okay, now I've got to do SADMEP, not PEMDAS. So I work from the outside in. I have to subtract 2 from both sides. I can't take 2 from x, so I just write down x minus 2 equals 2/5 y. And now I need to get rid of the 2/5. So, okay, so we're going to multiply both sides by the reciprocal of the coefficient of the y variable. In plain English, we're going to put parentheses around this and this. Now, you have to put parentheses around the whole left side because you're going to perform a distributive property. Now, the reciprocal is just the flip. So we're going to multiply by 5/2 on the right and on the left, 5/2. Now, the easy part is the right side. These all cancel, and we've isolated y. Okay? Just keep in mind that y is the inverse. So we've got it. We've nailed it. We've got y by itself. Read from right to left. Now we're going to distribute, okay, the 5/2 to both of these terms. So 5/2 times x is 5/2x. Now let's think about this one in side work. 5/2 times -2/1. Cancel, cancel. 1, 1. So now what's 5 times -1? It's going to be -5, right? We would have ended up with -10/2, and then you would have divided 10 by 2, gotten 5. This is just an easier way to do it. So we're just going to write minus 5. And that's it. I mean, that's equal to f inverse x. Okay? So let's write it out to make it look nice. The inverse of the function x is equal to 5 over 2 x minus 5. Done. We are done with number 8. All right, ladies and gentlemen, here we are on number 9. So it's asking us to do a composition of functions. Whenever you see this, f open parentheses, g open parentheses, what you're seeing is f of g of x, right? Well, this is equivalent. Now you're learning a new mathematical symbol, congruent, equivalent to this thing from your test. You remember this? The composition of f and g of x. It's the same thing. So step 1 is to find f of g of x. All right, that's what we're going to do first. So first, we're going to find, write small, f of g of x. We don't care about the 4 just yet. So we're going to set that equal to, we're using f as the frame. F is our frame. So we write 2 open parentheses where we see the x, and then leave a big space, like that big, okay? And then put plus 5. Now inside the frame, we write what g of x is, which is 4x minus 6. Okay, this isn't that hard. We got this. Let's choose a cool color here. How about green? All right, now we're going to distribute the 2 through both terms right there. And we have f of g of x equals 2 times 4x is 8x. 2 times negative 6 is negative 12 plus 5. Okay, these are common terms. We combine these. So now I have f of g of x equals 8x. Negative 12 plus 5, ladies and gentlemen. Is that negative 7? Negative or positive? Negative 7. Minus 7. 8 and 7 have no common factors because 7 is a prime number. Therefore, it's fully reduced, and we're ready to evaluate at 4. Ready? So now this is part 2. Evaluate f of g of x at x equals 4. Okay, so here's how that looks. F of g of 4 equals 8 open parentheses 4 close, this is the easy part, minus 7. So f of g of 4 equals 8 times 4, 32 minus 7. What is that, 25? Yeah? So f of g of 4 equals 25. Can anyone say it in Spanish? Yep. Good job. So just remember, that 4 right there, that's an x value. That 25, that's a y value. If you were to go on Desmos and plot this, and then plot 4, 25, you would find that that point lay on that line. And that is the end of number 9. All right, ladies and gentlemen, here we are with number 10, and it looks like we're moved on to absolute value. So here's the deal. I have to get the absolute value part by itself before I can do anything. So the first step, or first set of steps, is going to be to actually get the absolute value by itself. And so we have to work from the outside in, SADMEP. So I'm going to start by adding 8 to both sides. Okay? All right. Okay, then I can divide out the 2. We can make this bigger now. No, we don't. We want to keep it small. All right, let's see where we're at. That cancels. So now I have 2 absolute, I'll zoom in on it. We have 2 absolute value, 3x minus 1 absolute value equals negative 6 plus 8 is positive 2. Well, okay, so now I'm just going to divide both sides by 2. Okay. Divide both sides by 2. This is going to be a difficult problem. Those cancel, and then these cancel, leaving behind 1s. So we just have the absolute value of 3x minus 1 equal to 1. Now you ask the question, is the absolute value equal to a positive number? Yes? Yes. Okay, if no, then no solution. But if yes, proceed by creating tree. So we write 2 equations. 3x minus 1 equals 1. And 3x minus 1 equals negative 1. Now we solve. We solve by adding 1 to both sides. I usually solve in a row, like I solve these at the same time. So on the left there, I've got 3x equals 2. And on the right there, I've got 3x equals 0. That's okay. That's not wrong. So now I'm going to divide everything by 3, right, to get the x by itself. The 3's cancel, so I have x equals 2/3, or approximately 0.6666, okay, ish. And then over here, I've got x equal to 0. And so those are your 2 possible answers. Now, it doesn't state that you're supposed to search for extraneous solutions. We can, I guess, assume that there aren't any, okay? It would be really easy to check. I'll just quickly do it in my head. 3 times 2 is 6 over 3, which is 2, minus 1, which is 1, equals 1. And then 0 minus 1 equals negative 1. The absolute value negative 1 is 1. Okay, both of them work out. I just did it. So they're both neither are extraneous. So the way you write the solution is like this. You use these braces and you put the smallest number first, which would be 0, comma, and then we'll just write 2/3. Let me close those braces off, okay? And that is the end of number 10. All right, ladies and gentlemen, here we are on number 11. This is the sum of functions. We're going to add 2 functions together. The first function is f of x. The second function is g of x. So let's write out what we're going to do. We will sum f of x and g of x, which is going to look like this. The sum of functions f and g of x. Okay, that's what it looks like. Now notice something. This is what I've been talking about the whole time. They're not asking you to evaluate anything. They're just asking you to write the sum of the functions. This is what I've been talking about, people. Here we are. So let's do it. So use this, what am I trying to say, notation. The sum of functions f and g of x is equal to, and this is the really easy part, we just write down what f of x is and what g of x is. So I'll use some different colors to make sure that that's set apart. We'll make the f of x green. Minus 5x minus 7, or negative 5x minus 7. And then we'll use orange plus, so the thing is, you got to remember, if that leading digit is positive, you're going to use a plus symbol. Plus 2x minus 3. You don't need any parentheses when you're adding functions. You need them when you're subtracting functions, though. So now we just combine like terms. So let's play a little game of combine like terms. I spy this and this to be combined, and then I also spy this and this to be combined. So we'll just combine these two together, and then we'll combine these two together. Couldn't be easier. So the sum of functions f and g of x is equal to, what's negative 5x plus 2x? Negative 3x, negative 3x. And then what's negative 7 minus 3? Negative 11? Negative 10? Pardon me. Negative 10. Do 3 and 10 share any common factors? Why? 3 is a blank number. Say it. Starts with a P, ends with an E. Prime. Yeah. So there are no common factors, fully reduced. This is it. We're done. Number 11 finished. And here we are with number 12. So once again, we're trying to find the solutions to an absolute value equation, but we can't yet because we have to get the absolute value by itself, and we can't do that until everything is on the other side of the equal sign. So first things first, let's add 6 to both sides. Okay, zoom in on this for you. So now I've got 3 absolute value, 3x minus 5. Absolute value equals, and then that's going to be positive 3. Oh, this is the same one like before. So now what we're going to do is divide both the left and the right side by 3. And look what's going to happen. It's going to cancel, cancel. These become 1s. Cancel, cancel. These become 1s. And so now I've got the absolute value isolated by itself. Absolute value of 3x minus 5, absolute value equals 1. Okay. Is 1 positive? Yep. So we can continue. Do our little tree. So now I've got 3x minus 5 equals 1. And I've also got 3x minus 5 equals, what do I write here? Negative 1. Good job. Negative 1. All right, now let's solve. So here I'm going to add 5 to both sides. Here I'm going to add 5 to both sides over here as well. So 3x equals 6 and 3x equals 4. Divide, 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 divide. Everything's getting divided by 3. Okay, and that's great because that means that the x is by itself, and we found the solution. X equals 6 over 3 is 2. X equals 4 over 3, which is 1 1/3, or 4 over 3, right? So we can plug that in real quick in our heads. Let me show you what I'm doing. I'm plugging in this number right here, all right? So let's just do it. 3 times 2 is 6 minus 5. 6 minus 5 is 1. Absolute value of 1 is 1. 1 equals 1. That's true. Okay? Now I'm going to plug in 4/3. So 3 times 4 is 12. 12 divided by 3 is 4. 4 minus 5 is negative 1. The absolute value of negative 1 is positive 1. 1 equals 1. Therefore, both solutions are true. You see how quick you can do it? You can do it all in your head. You use this one to do your plugins to check for extraneous solutions. So there aren't any. And I didn't expect there would be because they usually will tell you. Which one's a smaller number? 4/3 or 2? Remember, 4/3 is 1 1/3, right? So I should list 4/3 first, then 2. Okay. And we are done with number 12. All right, ladies and gentlemen, here we are with number 13. We have the sum of functions. We've already done this a million times. So let's just jump into it. We're going to do the sum of f and g, okay, of x. So that's going to be equal to, I'll just use the same color because you kind of know what's up at this point, 4x minus 2 plus 3x plus 7. And it's just a game of combine like terms. So I spy like terms here, and I also spy like terms here. Okay? So we're going to combine these together and combine these together to get the sum of our functions f and g of x equals 4x plus 3x is 7x. Negative 2 plus 7 is 5. Well, 7 and 5 are both blank numbers. What's the word I'm looking for? Prime. So they can't be factored. Therefore, we're done. We're done with number 13. Okay, we are on number 14, and it's asking us what are the solutions of, and then it gives us an absolute value equation. Now, in order to evaluate the absolute value equation or solve the absolute value, we have to get the absolute value by itself. So before I do anything, I've got to get rid of this 1/2 right here. And in order to do that, I need to multiply by something. It starts with an R. Reciprocal, very good. What's the reciprocal of 1/2? 2 over 1, very good. So what we're going to do is we're going to multiply both sides of this equation like this by 2 over 1. And over here we can just multiply by 2. We don't need the over 1 part. And now the 2's cancel. Okay, so now the benefit of doing that is we're able to cancel out everything. So now we've isolated the absolute value. So now we have the absolute value of x plus 2 equals 8. And then we ask ourselves, is 8 a positive number? Yes, it is. Therefore, we can continue. If 8 had been negative 8, we would have said no solutions. But it's positive, so we keep going. So we write x plus 2 equals. X plus 2 equals. Over here on the left, we put the thing that's there, 8. And then we put a negative sign in front of the thing that's there. So over here, it's negative 8. And now we just solved both little tiny problems, okay? So we'll do minus 2, minus 2. I solve them at the same time, so I just kind of minus 2 everywhere. And then, so now on the left, x equals 6. And on the right, x equals negative 10. The question is, are these both valid solutions? Well, you can do this in your head. You take this number, okay, and you plug it in for the x. 6 plus 2 is 8. The absolute value of 8 equals 8, therefore it's true. Then you do the same thing here. You take the negative 10, you plug it in for the x. Negative 10 plus 2 is negative 8. The absolute value of a negative number is positive. The absolute value of negative 8 is 8. 8 equals 8, therefore it's true. So there's no extraneous solution. So we write out our full solution set like this. Open brace, smallest number first, negative 10, comma, 6. Close brace. And that is the end of number 14. Okay, here we are on number 15. And it's asking us to do composition of functions. So the way they're writing it, where they do the f of g of x, this is an equivalent way of writing this. The composition of f and g of x. Okay, so we can use either notation style, right? We'll use their notation style. So the first step, this is step 1, is to actually find f of g, of g of x, not of -5, but just f of g of x. So what we start with is the skeleton using the f function. So we're going to write 2, and then where the x is, we put a huge open parentheses like this. Okay, because we're going to stick this whole thing inside that open parentheses in a second. And then we put plus 4, because that's the framework of f. Now inside, we're going to put 7x minus 5 right here. Okay? All right, so there's just a little bit of distribution going on. So we have f of g of x equals 2 times 7x is 14x. 2 times -5 is -10. And then we just tack on that plus 4. And then we just combine our common terms. -10 plus 4 is -6. So we have f of g of x equals 14x minus 6. The only common factor is 2. So if I were to divide out a 2, okay, it's going to make the math easier. That's why we do it this way. This is like reverse distributive property, okay? What I end up with is f of g of x equals 2, open parentheses, 7x minus 3. I just divided out a 2. That's going to help us in a minute, okay? Because now we're going to actually evaluate at -5. So here's step 2. We're going to eval f of g of x at -5, okay? So here's how that looks. F of g of -5 equals, and here we're going to use this and plug in the -5 where the x is, okay? So we're going to write 2, open parentheses, 7, and then I'm going to put open parentheses, -5, close parentheses, minus 3, close parentheses. Let's keep going. We leave that 2 alone. Inside 7 times -5, that's -35, minus 3. Okay, so -35 minus 3 is -38. So now I've got 2 times -38. Well, I don't know what that is, so I just do 38 times 2, and I get 16, 6, 7, 76. Do people agree? 16 plus 60? Yeah, 76. It's going to be -76. Therefore, okay, f of g of -5 equals -76. And you know, that's your answer. Right, if we were putting this in a box, that would be your answer right there. And that is the end of number 15. All right, here we are at number 16, and we're finally on to the fun stuff, solving and graphing inequalities. Absolute value inequalities. Absolute value inequalities always result in what we call compound inequalities. That's 2 separate inequalities. So the first thing that you do is you look and see if the absolute value is by itself on the left. Yes, it is. And then you look and see if the right side is negative. So the right side's positive, so we can continue now, okay? So what we do first is we make our little branching tree structure, okay? Now remember the rule. So we're going to write 2x plus, you drop the absolute value bars, right? 2x plus 1 less than or equal to 24. And then you do the same thing over here, 2x plus 1, but now you flip the inequality symbol, Now it's going to be greater than or equal to 24. And then you negate this thing. So this is greater than or equal to negative 24. So you got to remember to flip and negate. Flip and negate. Okay. And now we just solve. Remember, if you multiply or divide by a negative number, you have to flip the inequality symbol. We're not going to do that in this problem, though. So we're going to subtract 1 from both sides. We'll do these one at a time. Now I've got 2x less than or equal to 23. And then we're going to divide both sides by 2. So x is less than or equal to 23 halves. Let's estimate that out. So 2 goes into 23 12 times with 1 as a remainder. No, 13 times, right? 12 times 2 is 24. 11 times. So it goes in 11 times with 1 as a remainder, so it's 11.5. Am I right about that? 23 halves is 11.5? You think about it. 2 goes into 22 11 times. There's 1 remainder. So it's 1 half, yeah? So we write 11.5. All right, and now we'll do the right one. Minus 1, minus 1. Oh, this one's going to be another thing we're going to have to estimate. So 2x is greater than or equal to negative 25, which we're then going to divide by 2. So now x is greater than or equal to, now we got to say, how many times does 2 go into 25? 12 whole times with 1 as a remainder. So it's 12 and a half, 12.5, negative 12.5. Negative 12.5. Okay? So now, what you want to focus on next is this inequality symbol. How do we say this? Yeah, this is LEQ, less than or equal to, okay? And so let's go to our chart here, less than or equal to. Which one are we going to use, the union or intersection? Intersection. So we're going to look at the part where they overlap, the middle part of the Venn diagram. All right, let's head back. So we're just going to graph now, okay? Are we doing open circles or closed circles? Closed circles on both, right. So let's use some different colors here. I'm going to do this one in blue. So I'm going to go to 11.5, which I'll just forget the number line, all right? You just make it up. So we're just going to make this be 11.5. And then down here, I'll do this one in red. We're going to make this down here be negative 12.5. Okay? I don't care about if it's to scale. I don't actually think you could do it to scale, given the number of tick marks there. So anyway, now what? Right? So you ask yourself, well, what's the blue one doing? The blue one is going to the left forever. Okay? So what you want to do is you want to make this big so it's really obvious. Draw a little thing like this. Get your ruler and then make it go off to the left forever, down to negative infinity. Okay? Now we do this one, negative 12.5. X is greater than negative 12.5. So that means that starting at negative 12.5, we're going to draw a little arrow up, a little line up, and then get our protractor. We're going to send this guy to the right forever. Okay? Out to positive infinity. This is literally what you want to do. Now this is where having a highlighter is super helpful, because it's going to be this shaded region. Remember, we're looking at the intersection, so we care about the shaded region, including the points, because it's LE less than or equal to and greater than or equal to. So there's your graph, okay? Like the part that needs to be colored in is this part right here. This is what we're concerned with right here, that middle part there. Okay, but we haven't written the solution yet. So now we're going to write the solution. And this is a little bit confusing. So here's how you write the solution. We're going to use this notation where we begin at negative infinity and we go to 11.5 because that's what this one says to do, the blue one, okay? And that's included, so we use a bracket to close it off. And now we go back to our Venn diagram, and it tells us what symbol to use. We're going to use the intersection symbol, which is the upside down horseshoe looking thing, okay? So then we draw this symbol, okay? That means intersection. And then we start at negative 12.5. We're using this bracket because it's inclusive. Negative 12.5, comma, infinity. And then you close, you always, with infinity, you always end with parentheses. So there's your two, it's a two-part answer, right? Here's your solution. And you've got the graph right there, okay? And that is the end of number 16. Okay, here we are on number 17. And this is another composition of functions problem. First, we're going to find f of g of x. So step one is to find f of g of x. Okay, and that's going to be equal to, remember, we're using f as the framework. So we put a 5, and then we put a huge open parentheses and leave a big space because we're going to stick this thing in there, okay? And then we put minus 7 because that's part of f. Now we stick in g. Let's make it green to go with the color. So we put 4x minus 3 right here. Okay, then we just distribute. Going to distribute the 5 to both terms of the parentheses there. So now I've got f of g of x equals 20x minus 15 minus 7. And then we have common terms here, negative 15 and negative 7. What is that? Negative 22? Yep. So therefore, right, f of g of x equals 20x minus 22. And I can definitely divide a 20 out of both of those. Or, no, I can divide a 2. Because if I divided a 20, I'd have a decimal. So let's do a 2. Let's divide out a 2. So we're going to divide out a 2. Okay. And what that's going to give us is f of g of x equals 2, open parentheses, 10x minus 11. Right? Because this makes it easier when we actually do the evaluation. So now we're going to evaluate. This is the part that we get the answer at. So this is part 2. We're going to evaluate f of g of x at negative 3. So what does that look like? Well, f of g of negative 3 is going to be equal to 2, open parentheses, 10, and then we use open parentheses, negative 3 minus 11, like that, okay? I'm getting the equation from here, okay? And I'm just plugging in x. Well, let's continue. So first we do the inside, leave the 2 out there. 10 times negative 3 is negative 30 minus 11. So that's going to be getting bigger negative. So what is that, negative 41? What's 2 times 41? Good, that's good. So it's negative 82. So f of g of negative 3 equals this. So f of g of negative 3 equals 2 times negative 41. And f of g of negative 3 equals negative 82. That's the answer. Okay. And we are done with number 17. Okay, for number 18, I do recommend having some scratch paper. We're going to rewrite this on some scratch paper because to solve this, we're going to end up with some weird fractions, and you'll see. So we're doing this inequality thing. We can't do anything till we get rid of the 3. So what I'm going to do is copy this over to some scratch paper, and then we'll work it from there. Okay, so we are now going to continue here. I've got the problem copied over to some space where we can write more. Now, first things first, we've got to divide both sides by 3. Okay. So I've got now the absolute value of x plus 1 over 4. Absolute value. I didn't divide by a negative, so it's still less than. And then we're going to leave this as a fraction, 13 over 3. Okay? I've already worked this out trying to do the decimal route, and it gets very complex. So let's do it this way. Now we've got an absolute value, then an inequality symbol, and then a positive number, right? So we can go ahead and do our branching tree structure. So I have x plus 1 over 4 less than 13 thirds. And then I've got x plus 1 over 4 greater than negative 13 thirds. Now, I can tell you there's only one way to combine these fractions, because we're going to have to subtract 1/4 from both sides. And that is to take 1 over 4 and 13 over 3 and think of what is the lowest common denominator. 12, right? It's 12. So I need to make both of these have a common denominator of 12. So what do I need to multiply by 1 over 4 to make its denominator 12? 3/3. You can only multiply by something that reduces down to 1. And so then 13 thirds needs to be multiplied by 4/4. Okay? It's been a while since you've done stuff like this, so it's okay. So that's going to result in 3/12. And then this one, I don't know what 13 times 4 is. So we do the math. 52. That's going to give us 52/12. Okay? So now, from now on, we're going to replace these numbers. So I'm going to write x plus 3/12 less than 52/12. And then x plus 3/12 greater than negative 52/12. Now I have common denominators, so I can subtract. So I'm going to subtract 3/12 from both sides. Just like that. And over here I get x is less than 52 minus 3 is 49, right? So 49 over 12. Did I do that right? Does that sound right to y'all? So how many times does 12 go into 40? Okay, so now we need to kind of estimate. We're not going to be able to solve this out, but we're going to estimate this to a decimal point. And so the question is, how many times does 12 go into 49? And we said it was 4 times, so x is less than 4. There was a remainder of 1. 1 divided by 12 gives us like 0.8. So it's something like 4.8, okay? And then it just, we don't need to keep going. We'll just leave it there. This is approximate. You might want to say approximate. But we just want to know where to put it on the number line. That's why we're doing it that way. Okay, so now here we are over here. And now I've got x is greater than, now I'm subtracting a negative from a negative. So it's going to be negative 55 over 12. Same, right? Is that right? Negative 55 over 12. So how many times does 12 go into 55? Is it still 4? So 4 times 12 is 48. 5 times 12 is 60. So yeah, it's still 4. So our, x greater than 4. What's the remainder though? The remainder is 7. 7/12. Okay? So try to figure that out as a fraction. 7 divided by 12. 70 divided by 12. How many times does 12 go into 70? 5 times? Good. So it's 4.5 something, right? Because 5 times 12 is 60, then there's a remainder of 10, so it's going to be like 4.58 something, something, something. Okay? But it's going to be negative, remember. Negative 4.58. So we've kind of got it right. We got it. Now we can graph it, yeah? So now let's take what we've got and go back to our problem. So we're basically just going to put some dots down. I'm going to do blue for the first one, and then I'll do red for the second one. So for my blue dot, is it going to be an open circle or a closed circle? Open circle, right? Okay. And before we go any further, we better analyze this symbol here and figure out what we're doing. So let's figure out what we're doing. Are we doing the intersection or the union? Intersection. Good. Okay. So I'm going to plot 4.8 and negative 4.58. So in blue, I'm going to put 4.8. I'm just going to put that here. I don't really care about scale. This is like 4.8. Okay. And then, oh, I'm on the wrong one. Sorry. Thank you for pointing that out. So here I'm going to put like 4.8. And then down here I'm going to put, oh, but it's going to be an open circle. So like this. Right? And then over here I'm going to put negative 4.58. And now let's look at those inequality signs. X is less than 4.8. So from 4.8, I'm going to draw a little line going up, but not in red. I want it to be blue. Okay, and then we take our ruler, and that's going to the left forever. Okay, to negative infinity. And then hopefully, so x is greater than negative 4.58. So here I'm going to take my red and go up and then do a right move forever to positive infinity. And we already said it's the intersection, so we're going to graph the middle part, and this time we'll do it with the purple. Okay, I'm graphing the middle part. Just remember that we're not including the numbers there, they're going to be all parentheses when we write out the solution. So here we go with our solution. Open parentheses, negative infinity, comma, and then it's 4.8. Or let's use the fraction, 49/12. Okay, aka approximately equal to 4.8. Okay. And this is also a parentheses. Now this is the intersection, so we use this upside down horseshoe to indicate that it's the intersection. And then we do another open parentheses here. Start at negative 4.58, but we're going to use the negative 55/12. Okay. AKA approximately negative 4.58, comma, positive infinity, there. And so those two pieces together form your answer. And that is the solution to number 18. Okay, once again, we're going to find f of g of x. And so this is number 19. So we're going to find f of g of x. Notice that it didn't ask us to evaluate it. It's asking us to do the thing that I keep hammering home. Just find f of g of x, which is going to equal 2, open parentheses, 4x minus 6, close parentheses, plus 5. Distribute the 2. That's going to equal 8x minus 12 plus 5, which is going to equal 8x minus 7. So f of g of x equals 8x minus 7. And that is the end of number 19. Okay, so for number 20, we're probably going to need to draw it on some graph papers or side work papers. So let's go ahead and do that. All right, so here I've got the side work going on. And the first thing we have to do in this problem is actually get rid of the 7. So we're going to divide both sides by 7. In order to isolate the absolute value. So now I have the absolute value of x plus 3 over 4 is less than 3 over 7. Okay, let's quickly analyze what we're going to be dealing with. This is another intersection, right? So, but let's do our split because 3/7 is positive. We have x plus 3/4 is less than 3/7, and we have x plus 3/4 is greater than negative 3/7. Okay, but the problem is we can't do 3/4 and 3/7, so we write them down and think about what is the lowest common denominator, and I think it's 28, right? So is that right? Yeah, so I'm going to multiply the 3/4 by 7/7, and I'm going to multiply the 3/7 by 4/4. And that's going to give me my common denominator of 28. So this is going to equal 21/28, and this is going to equal 12/28. So we're just going to replace that. We're going to write x plus 21 over 28 is less than 12 over 28. And then we're going to write x plus 21 over 28 is greater than negative 12 over 28. Okay, so now I'm going to subtract 21/28 from both sides. Okay, so x is less than 12 minus 21. Well, that's 21 minus 12. Is that 8? Negative 8? No, it's 11. So it's 9. Is that right? Negative 9? Negative 9 over 28. And then here, we're going to subtract 21/28. So here I've got x is greater than negative 12 plus 21. So I need to kind of add 12 and 21, and I get 33. So negative 33/28. Oh boy. So we know that the right side is way smaller than the left side. That's all we need to know. So just, this is how we do it. That's a Montel, what's the guy's last name? Okay, let's go ahead and graph it and get it over with. So let's make this one negative 33 over 28. And it's going to be an open circle. Okay, greater than, going off into infinity. And then I've got the less than negative 9/28. I'll just make that arbitrarily here, negative 9/28. It doesn't matter. And that's going this way off into infinity, to negative infinity. And then my shaded region is the intersection right here. Okay, that's my solution region. So my final written solution is, okay, so now let's write the solution. So this is kind of the hard part. It's all open circles, so it's negative infinity up to negative 9 over 28. Okay, intersects negative 33 over 28 to positive infinity. Okay? And you close the parentheses. So that is the end of number 20.